Okay, so yesterday we have discussed that the time period of a simple pendulum is directly proportional to the root of the length. Exactly, if you remember, yesterday we have discussed that on what factors the time period of a simple pendulum depends. Okay, now today we are going to discuss, we are going to extend our discussion, we will talk something more about it. Okay, so I'm sharing the same simulation what I did yesterday, the simulation of our simple pendulum. Okay, sure. So this is our pendulum. If you remember yesterday, we had a very important conclusion. Okay, and our conclusion was that the time period of a simple pendulum. Okay, the time period of a simple pendulum T is directly proportional to the root of L. Exactly, if you remember this, it was directly proportional to the root of L. Okay, so we have discussed this, that the time period of a simple pendulum is directly proportional. The time period of a simple pendulum is directly proportional to the root of L. This was the relation what we derived yesterday, that the time period was directly proportional to the root of the length. Yes, this was our relation. Now today we are going to discuss the actual formula for the time period. Okay, so the time period formula is, write down the time period, the formula for time period. If you want to calculate the time period, then the relation is T is equal to 2 pi. Now I cannot, chalo, 2 pi under L upon G. So it is 2 pi under root L upon G. The length divided by G. Okay, so let me type it, let me complete it by writing with hand. So the formula is 2 pi, this is pi, under root L upon G. This is our formula to calculate the time period of a simple pendulum. T is equal to 2 pi under root L upon G. Okay, so this is our formula. So now yesterday we have discussed that how the time period was related. Now we will going to talk about, how the time period is dependent on acceleration due to gravity. Okay, now yes, definitely. Tanishk, I am going to send this video on Google Classroom, not Classroom app. It's a Google Class. Okay, on your mobile, it's an app. Okay, no problem. Huh. What is G? G is Avni. G is acceleration due to gravity. Okay, so when anything is dropped, okay, beta, when anything is dropped from a height, okay, then when it falls, its speed keeps on increasing with time. When anything is been dropped from a height, its speed keeps on increasing with time. Okay, it keeps on speeding up. This is called as acceleration due to gravity, and this acceleration due to gravity comes out to be around 9.8 meter per second square. Okay, this is somewhere around 9.8 meter per second square. This is the value of acceleration due to gravity. We approximately take it 10. Okay, so we are going to find out, does it depend on the acceleration due to gravity? Okay, that is our topic of discussion. Okay, so we will take a standard value first. Okay, our length I'm taking is 1 meter. Our length is 1 meter. Yeah, it's okay, beta. We already take 9.8 only. We don't take Soumya, we don't take anything beyond that. It's 9.8, it's okay. And for the simplicity of calculation, we keep it 10 as well. Because 9.8, it is very close to 10. So this is the stopwatch. This is the pendulum. Okay, now how much is the acceleration due to gravity? So the acceleration due to gravity is here. You can figure out we are having some planets here. Okay, so the first planet we have taken is Earth. So how much is the acceleration due to gravity on the Earth? So acceleration due to gravity on the Earth is somewhere around 10 meter per second square. Now what we will do, we will find out the time taken for one oscillation if the length of the pendulum is 1 meter. Actually, we have done it yesterday, but still we will repeat it. Okay, I start the timer. I keep it here at around 20 degree. This is something I'm going to repeat. Okay, now I start the timer. I start the simulation. Okay, see, it's moving. It's going to one extreme and then it will come back. Let's find out the time taken. Exactly. How much is the time taken? So you find that the time taken is 2 seconds. Okay. So let me write down on Earth. The time for is 2 seconds. The time required is 2 seconds. This is on Earth. Okay. What's the characteristics of that? That on Earth the acceleration due to gravity is 2 seconds. The on Earth the acceleration due to gravity is around 10, and that's why the time period for the length as 1 meter is coming out to be 2 seconds. Now from here we go to moon. See, I've changed the option and now we are on the surface of the moon. And if you perform the same experiment, how much is the length we are going to keep? So the length we are going to keep will be 1 meter. Okay, and how much is the amplitude we are going to keep? We are going to keep the amplitude as 20 degree. And this experiment is now performed on moon. And let's find out how much is the time taken for completing one oscillation. Okay, so I keep it 20. Okay, and I start it. I have started the timer. Sure. See how much is the time it's taking. I think, see the time means you look at the motion. Okay, it's slow motion. I will make it little normal. See, and I make it slow, so that I want to pause it. Exactly. How much? So you will find on moon it is 4.92, means 4.9. On moon the time taken is 4.9 seconds. How much? 4.9 seconds. Okay, now we will reset this. See class, we are doing one by one. So we have done for Earth, we are done for moon. Now we will do it on Jupiter. Okay, let's go for Jupiter. Okay, this is the timer. I turn it on and I start. This is what we are performing on Jupiter. Okay, how much it is taking? If you find on Jupiter, the time it is taking is 1.27. So I will round it 1.3 seconds. Okay. So now what we conclude from these three observations? Okay. What is our important conclusion regarding the acceleration, regarding the time period of a simple pendulum on Earth, on Moon, and on Jupiter? Okay. So if you check it little carefully, you will find that the time period is very less on Moon. It is then, I can say, on Earth it is 2. I am arranging it in the increasing order, and then on Moon. Okay. So if you check it, you will come to know. Now, do you know if you do little bit of research, you will come to know that the acceleration due to gravity. Let's talk about this is our time period. Time period. Now we will talk about another important thing, that what is the acceleration due to gravity. Okay, so let's write down acceleration due to gravity. Acceleration due to gravity. Okay, now this is our another important. Now what we will do, class, the time period we got on Jupiter is 1.3, then on Earth it is 2, on Moon it is 4.9. But now what we will do, we will Google and we will find out how much is the acceleration due to gravity on Earth. We know how much is the acceleration due to gravity on Earth. Acceleration due to gravity on Earth is, we know that it is around 9.8. So I will write acceleration due to gravity on Earth. On Earth it is 9.8 meter per second square. Meter per second square. Okay, this is the acceleration due to gravity on Earth. But we don't know what is the acceleration due to gravity on Jupiter and acceleration due to gravity on Moon. So what I will do, I will pause this. I will stop this sharing. Okay, I stopped sharing this. Okay, let that screen be there and let me open. Oh, wait a minute. I should have continued with the same sharing. Wait. Okay, and what I will do, see here, I will on the Google, I will try to find out the acceleration due to gravity on Moon. Okay, see, I'm finding it. What is the acceleration due to gravity? So it is about 1.625 meter per second square. See, class, it's already been here. The acceleration due to gravity on Moon is 1.625 meter per second square. Okay, so so we will find out how much is the acceleration due to gravity on Moon. Just now we calculated is 1.6 meter per second square. Okay, now we will find out what the acceleration due to gravity. What's the acceleration due to gravity on? This is on Moon. Now we will find out how much is the acceleration due to gravity on Jupiter. On Jupiter, see how much it is. So on Jupiter, it is around 24.5 meter per second. See, you can see the result. On Jupiter, it is around 24.5 meter per second square. Okay. On Moon, it is 1.6. See, on Moon, it is 1.6. On Jupiter, it is 24.5. Okay. So let's go back here. On Jupiter, it is 24.5. Jupiter, it is 24.5 meter per second square. Okay, and we know how much it is on Earth. And Earth, it is around 9.8 meter per second square. So what you conclude, beta? If you remember regarding the time period, okay, if you remember regarding the time period, the time on Moon was less. On Moon it was more. Okay, on Jupiter it was less, and Earth it was 4. Okay, see, this was 1.27. This was on Earth, Jupiter. Okay, so let me type it again. This is 1.2. This 1.27 is 1.8. This was seconds on Jupiter. Okay, and we calculate it was 2.0 seconds on Moon, and I think this was on Earth, and it was 4.8 seconds, I think, around 4.8. Anyone remembers what was that? 4.9. Okay, very good. It was 4.9. Yes. So it was 4.9 seconds on moon. Clear? Now look at this relation class. Okay, look at this relation. This is a very interesting relation what we had opted now. Okay, regarding the time period and okay. So you find that on moon the acceleration due to gravity is 1.6 and the time period is 4.9. Okay, so you can have this very interesting relation, right? Regarding on moon, it was 1.6 meter per second square. The acceleration due to gravity is 1.6 meter per second square, whereas the time period is 4.9. On Earth, you will find that the acceleration due to gravity is 9.8 meter per second square and the time was 2. And on Jupiter, the time was 1.8 and the acceleration due to gravity is 24.5. So if you check it, you will easily come to know that on moon, the acceleration due to gravity is minimum, but the time taken is maximum. Yes or no? Look at moon. On moon, the acceleration due to gravity is 1.6, whereas the time taken is 4.9. And on Jupiter, the acceleration due to gravity is 24.5 and the time taken is 1.8. So what is the relation you find? You find that as the acceleration due to gravity changes, the time period also changes. But is it directly proportional or inversely proportional? So you can easily conclude that the time period is here, it is not directly proportional because where the acceleration due to gravity is less, like an example of a moon, the time period is more. And where the acceleration due to gravity is more, like Jupiter, the time period is less. So what we can say, time is inversely proportional. Inversely proportional to the root of acceleration due to gravity. Okay, write down. This is the relation. Okay, if you want to write it mathematically, it comes out to be T is inversely proportional to the root of 1 upon C. So it will go something like this. So T is inversely proportional to 1 upon root of under root G. This is the relation. Write down. This is the relation for time period. Okay. Remember, there are two important relations. T is directly proportional to root of L. And T is inversely proportional to the root of G. Okay. Please copy this. And write down these values as well. These are very important values. Beta. If you're copied, please type yes. If you're copied, please type yes. Okay. Very good. So this is the relation we have between T and N. Chalo, let's find out some more relations. Let's find out some more relations. Now we will find out. Let me reset it. And let me take the acceleration due to gravity as Earth. Okay. Now first we will find out the amplitude. Okay. So make a table like this. All of you make a table like this. Amplitude. Amplitude. And the second will be time period. So we are going to take different amplitudes. We are going to take amplitude as 5 degree, then 10 degree, then 15 degree, and then we will take 20 degree. And then if you want, I will take 25 degrees. And then subsequently, we are going to find out how much is the time period. Okay, so let's make a table like this where we are having a relation of time period and amplitude. Okay, so here, if I'm taking the relation, if I want to find out what is the relation between time period and amplitude of oscillation, okay, this amplitude of the swing and the time period, what I have to do, first of all, I have to take the other parameters constant. So what is constant now? So my acceleration due to gravity is constant. Then my length will also remain constant. How much length I have taken? 1 meter. Even I am going to keep my mass constant. So I am not going to change either the acceleration due to gravity, neither the mass, neither the length. Okay, the only thing I am going to change is the amplitude of oscillation. Okay, in the first case, I will take 5 degree of 5 degree, then 10 degree, then 15, 20, and 25. I want class quickly. I want your opinion. How you think it may be related? Quickly type your answers in the chat. I want to see before starting with the experiment. I want to see your opinion on this. What do you think? If the amplitude will keep on increasing as we have done in the table, what do you think about the time period? Give your opinion in the chat, beta. What do you think? Okay, it's about what do you think? Okay, okay, very good. So Avni has said more the time, more the amplitude, more the time. Very good. Swam has said, sir, more is the amplitude, less is the time. That is what Swam has to say. Aditya is saying, sir, the time will increase as the amplitude increases. Same is the opinion of Soham as well. He's saying, sir, as the time period will increase, the amplitude will increase. Om is also saying the same thing. Yash is also saying the same thing. Tanishk is also saying the same thing. Piyush is also saying, sir, as the amplitude increases, the time will increase. Nitya is also saying the same thing. I am having around 30 students in 34 students in the class. Come on. What about others? I'm waiting for other responses as well. Quickly type. Okay, Ria is saying, sir, as the time period will increase, the amplitude will, as the amplitude increases, the time period increase. Monish has given me one interesting answer. Okay, then Sejal is saying time period increases as the amplitude will increase. Okay, Raunak is saying more the amplitude, more the time period. Okay, then Nidhi is saying that time period will increase as the amplitude will increase. Very good. Okay, what about others? Bhumi is saying more the amplitude, more is the time period. Okay, brilliant, brilliant. I want these all responses beta. Okay, now let's start this experiment. Okay, so we are having, okay, Mahesh is also saying the time period will increase. Avni is also saying it is directly proportional. Vidula is saying that the time period will increase as the amplitude will increase. Okay. Okay, Priyanka is also giving the same opinion as that it will increase, and Soumya is also saying more the amplitude, more the time period. Brilliant. Thank you very much, Beta. Thank you very much. I'm so happy. I want this active participation from your end. Okay, chalo. So as I told you, I'm not going to change anything now. I'm only going to change amplitude. My mass will remain constant, my length will remain constant, and more interestingly, my acceleration due to gravity is also constant. Okay. So I pause it. Now, what I will do, I will take the degree of oscillation as 5. How much is the degree of oscillation I'm taking? So I am taking the degree of oscillation to be 5. Okay, that's my degree of oscillation. Okay, how much I will take? Wait a minute. So I will take it 5. Can you see 5 there? This is 5. Okay, I started the timer. This is 5 degree. Okay, how much is the amplitude I have taken, beta? 5 degree. I have started the timer and let me start. Okay. Let's find out how much is the time taken for 5 degree. Okay, how much? 1.98. Exactly, means it's 1.98. I round it, it becomes it becomes 2 seconds. Okay, so how much is the time for 5 degree? Okay, I'm writing it. So the time is coming out to be 2 seconds. This is for 5 degree. Okay, class. Now I will find out how much is the time it will take for 10 degree. Okay, so I'm increasing it now. See, I'm increasing it and I'm increasing it to 10 degree. I've done it 10 degree. Okay. I will reset this and I will start. Now we are taking the amplitude as 10 degree. Oh, wait a minute, wait a minute, wait a minute. I have not started the timer. This is 10 degree. I start the timer and I start it. Okay. See how much time it will take for 10 degrees now. It's oscillating, it goes to one extreme. See how much time it take? It take 2.05. So we'll round it to 2 only. So how much is the time it is taking for 10 degree? For 10 degree, it is taking 2 seconds. Clear class? For 5 degree, it took 2 seconds. For 10 degree, it's taking 2 seconds. Clear? Now let's do it for 15 degree. Okay, so let me reset this. I reset it to 0. Okay. And now I'm increasing and I will go for 15 degree. This is 15 degree. Yes. Okay. This is 15 degree. Let me start the timer. Okay. So amplitude of oscillation is 15 degree. Let's find out how much is the time it will take. 5 degree it was 2. 10 degree it was 2. It is little bit microseconds here and there, but it's okay. We can round up that. Okay. See how much it is taking. Look at the timer. Look at the timer here. Okay. You can find out that it's coming out to be 2 seconds for 15 degree as well. So for 15 degree, we find that the time taken is 2 seconds. Okay. Now I will reset it. I will reset it. Okay. I will turn on it. And now I will take 20 degree. Okay. How much I will take? I will take the amplitude as 20 degree. This is 20 degree. Clear? Now let's start the timer is on. Let's start it. It's 20 degree. Let's find out. It's moving from one end to the other. Okay. And then again coming back towards the initial. Clear? Yes. And how much it takes, beta? Look at the timer again. It's 2.03. We'll ignore that 0.03. And how much is the time it is taking? So you will find that the time taken for 20 degree oscillation is also 2 seconds. Okay. So for 20 degree oscillation, we find that the time taken to complete one oscillation is 2 seconds. Now let's take it for 25. Okay. Let's take it for 25. Okay, let me reset it. Let me on it. Now I'm taking the amplitude of the swing as 25. This is 25 beta. Okay, now I will start it because the timer is already set. Let's find out how much is the time it will take if the amplitude of the oscillation is 25. See how much it is 2.02. Again, if I round it, my answer is coming as 2 seconds. Okay, so now class, I want all of you, since this experiment is performed in front of you, I want all of you to conclude your opinion. Okay, all of you have given and said, sir, as the amplitude will increase, the time period will increase. But the table is there in front of you, which says that as I am increasing the time amplitude, the time period is still the same. Yes. Yes, very good, beta. Wait a minute. Avni, what do you say, sir? Can we take it as 2.1 second? No, beta. It was 0.2 now. Exactly. And we find that in all the cases, yeah, point 0 is okay. But in the rest, all the cases, you find that the time period does not change. So the time period is constant. Even if the amplitude increases, the time period remains same. All of you, very good, Soumya. Right answer. Sanika, time period remains constant. As the amplitude increases, the time period is constant. Very good, Ria. This is what I want all of you to conclude on your own. Okay, so what we concluded? We concluded that though I am increasing the amplitude of the swing, still the time period is constant. So write down, very, very important conclusion. Write down, write down. The time period, write down this conclusion, beta. The time period of oscillation does not depend on the extent of swing, on extent of swing in the bracket, write down amplitude. Extent of swing is nothing but amplitude. Write down. This is our very important conclusion we drawn today, that the time period of oscillation does not depend on the extent of swing. That is nothing but amplitude. Please copy this. Yes, very good, Piyush beta. As the amplitude increases, the time period remains constant. Means it does not depend. We observed that the time period was dependent on length. As the length was increasing, the time period was increasing. As the acceleration due to gravity was increasing, the time period was decreasing. But here we observe that as the amplitude is increasing, the time period is still the same. Clear? Have you copied it? If you have copied, type yes so that I can show you one more important activity, a very interesting and mind-blowing activity. Okay, okay, very good. Chalo. So let's start with the another one. Okay, I will clear this now. Now, what we will do, write down. The another table we are forming. The first is mass of the bob. Mass of the bob, and the second factor is time period. So we are going to find out what is the relation between the mass of the bob and the time period. Chalo. Make a 2-column table like this, a mass of the bob and the time period. The mass of the bob and the time period. Chalo. Make a table like this. Now here what I am going to do, so I am going to take different mass. Okay. Okay. So what I am going to take, so first I am going to take the mass as, okay, I am giving you the values. So mass I am going to take first as 100 gram, then 300 gram, then 500 gram, then 700 gram, okay, then 1 kg, which is 1000 gram, and then we will directly jump to 1.5 kg. Okay, 1.5 kg. These are our readings we are having for the mass of the bob. Okay, and now what we will do, we will keep, wait a minute, beta, Nitya, wait, beta. Now what we will do, we will reset it. I will reset this as well. Now, what I will do, again, I'm only going to change the mass, but here also, I'm going to keep the amplitude same. Okay, I'm going to keep amplitude as 15 degree in all the observations. So my amplitude will always remain 15 degree. My length will always remain 1 meter. The only thing I'm going to change is now the mass of the bob. Clear? So here you find this is the mass parameter. Can you see? See, I'm increasing the mass and the size of the bob is also changing. Can you see this, beta? Okay, so now you find here as I'm increasing the mass, the size of the bob is increasing. Means I can change the mass. Okay, so remember now how many readings we are having? 3 plus 3, 6 reading we are having. But before starting with this reading, okay, yeah, before starting with this reading, what do you think as the mass of the bob will increase? What do you think the time period? So Nidhi has given the answer. Sir, heavy the mass, more will be the time period. That's the answer of Nidhi. Okay, very good. Type your answers, bachcha log. Avni is saying time period will increase with mass. Swam is saying more the mass, more the time. Okay. Nitya is saying no, time will not change. Okay. Soumya is saying more the mass, more the time. Nishant is saying time will be same. Piyush is saying mass of the bob increases, time period will increase. Okay, Ria is also saying the same thing. Soham is also saying Soham is saying time decreases as the mass increases. Okay, okay. Riyansh is also saying that the time will decrease. Om is saying that the time will remain same. Nirmit is saying more the mass, more the time. Okay. Rishi is saying the time will not get affected. Very good. So I am getting three reasons now, three answers. Okay. Some of you are saying that the time period will increase. Some of you are saying the time period will decrease. And some of you are saying, interestingly, that the time period will not change. Okay. Very good. So some of you are saying it will increase. Some of you are saying it is decrease as well. Whereas some of you are saying it will remain the same. So what I will do now, I will do one thing. We will start with our activity. What are the constants? The amplitude will always be 15 degree. Okay, chalo. So my timer is on. Okay, I keep it to 15 degree. This is 15 degree. I start the timer. Chalo. Let's see how much is the time taken for 100 gram. What is the mass of this bob which is oscillating? It's 100 gram. Okay. How much it is? Stop. How much it is? It is 2.01. Please, all of you write down. It is 2. Okay, chalo, let me write it here. It is 2. It's 2 seconds. Okay, chalo. For 100 gram, it is 2. I reset it. I reset it, and now I will reset this as well. And I will change the mass to 300 grams. See, so I'm increasing the mass from 300 grams, which is 0.3 kg. Can you see here? I've done it 0.3 kg, which is 300 gram. Okay, so the mass of the bob is now 300 gram. Now I increase it, and my amplitude, as I said, it's always going to be 15 degree. Okay, so this is my amplitude, and let me start the time. Let's find out. Now the mass is 300 gram. Earlier it was 100 gram. Now it is 300 gram. See how much it is. Look at the timer here. Okay, but chalo. So you find it is coming out to be 2 seconds. Here, how much is the time? You find that the time for 300 gram, when the mass of the bob is 300, the time is 2 seconds. Okay, chalo. Let me reset it again. This is, let me reset it. And how much is the next 500 gram? Okay, so it will be 0.5. Say I'm increasing the mass. How much is the mass I have taken of this bob? 0.5 kg. Okay. Amplitude of the swing has to be 15 degree. This is the amplitude of the swing. The timer is on. Start. Stop. Okay. How much? Look at it. It's 2.04. Obviously, I can, even if I round it, it's not becoming 2.1. So it's still 2 only. Okay. So how much is the time taken for 500 gram as well? 2 seconds. Okay. Chalo. Now, quickly we will reset it. And now I will take the mass of the bob as 700. So I'm increasing it. 0.7 kg I will do. 0.7 kg. The amplitude of the swing will be 15 degree. Okay, let's start. See, how much? 1.98. If I round it, it comes out to be 2 again. Okay, so how much is the time? I'm rounding it to 1 decimal places. So it's come out to be 2 seconds. Okay, then let's do it again. Okay, let me reset it. Now I will reset this as well. Now I will take the mass as 1 kg. Okay, how much is the mass? 1 kg. This is 1 kg mass. Okay, Let's keep the amplitude as 15 degrees. See, this is my 15 degree. Let's start. How much? 2.02, obviously. So that is quite insignificant. So again, I make the time as for 1 kg, it is still coming out to be 2 seconds. How much it is for 1 kg? 2 seconds. Now, the last one, directly I will take the maximum, that is 1.5. Okay, let me reset it. See, I increase the mass of the bob to 1.5. I reset it and let me take the amplitude as 15 degree. This is 15 degree. Let's start. Yes. How much? 2.01 means if I round it, it comes out to be 2 seconds. How much it is? 2 seconds. So class, please write down this and let's look at your opinion. Okay. Yes. Very good, Ria. What happens? And most of you have said this answer as well. What we observe, beta? We observe that as the time period is increasing, sorry, as the mass of the bob is increasing, the time period does not change. Please remember this. This activity is for you people only. Okay. अभी तो हमको समझ में आ रहा है, लेकिन एग्जाम में जब यही क्वेश्चन पूछा जाएगा ना, you may end up giving wrong answers. So please remember, what is our important conclusion now? Our important conclusion is write down. Write down. Time period of oscillation does not depend on the mass or material, because even if the material will change, the mass will also change of the body suspended. Exactly. Write down. This is a very important conclusion. Okay. So the time period of the oscillation does not depend on the mass or the material of the body. So understand on what two factors it depends. It depends on the length and it depends on the acceleration due to gravity. The time period. The time period depends on the root of the length. T is directly proportional to the root of the length, and T is inversely proportional to the root of acceleration due to gravity. But the T, it does not depend on, the amplitude of the swing, and the same way just now we saw that the time period also does not depend on the mass of the bob. Nidhi, you are asking me, can you explain it? Beta, what explanation you want? Can you say me little more clearly which explanation you want? I'd perform an experiment. Beta, this is what we observe. In physics, we always find out what is our observation. Okay, so we observe, yes or no, we had performed this experiment and we observe, this is what we are supposed to do. So we are concluding, we are observing, and we say that even if our time mass of the bob is being changed, but still the time period remains unchanged. Why? Because the time period of the oscillation does not depend on the mass of the bob, neither it depends on the material of the bob. This is the observation. That is what physics is all about. You observe and you say how they are related. Okay. Now, understand, so on what two factor it depends and on what two factor it does not depend. And I want all of you to be very careful about it, that it does not depend on the amplitude of the swing, neither it depends on the mass of the bob. Okay. So in the exam, this type of questions will come, that assume that a wooden bob is there and an identical iron bob is there. Okay, so which will have more time period for the given length. So you have to understand it's a wooden and it's iron. So obviously the mass will not, even if the mass will change, the mass will have no effect on the acceleration due to gravity. Clear, bachcha log? All of you getting it? Okay. Yes. I told you na beta. Remember the time period depends on two factors. Avni, the time period depends on two factors. Which are those two factors? The first is it is directly proportional to the root of the length. T is directly proportional to root of length. What we discussed yesterday. Okay. Then we observed today that T is inversely proportional to the root of acceleration due to gravity. Yes or no? Miss, we see no. We have performed one experiment on Earth, one on Moon, and one on Jupiter. Yes, and we observed that the time period was changing. Exactly. So it depends upon the length. It is directly proportional to the root of the length, and the time period is inversely proportional to the root of acceleration due to gravity. So these are the two factors, Avni, on which it depends. And what are the other two factors on which it does not depend? So it does not depend on the amplitude of the swing, neither it depends on the mass of the ball. Clear? Okay. Chalo. Now write down another very simple definition, simple concept. Just write down. I hope you had copied this. I'm clearing it. Okay. Chalo. Write down next. Next definition. It is seconds. Seconds pendulum. Write down the heading. Seconds pendulum. And what the seconds pendulum says? A pendulum with a time period of oscillation equal to 2 seconds is known as seconds pendulum. The length of seconds pendulum at a place where G is equal to 9.8 meter per second square is nearly 1 meter. Write down. This is a very important thing about one the pendulum we have. That pendulum we called as seconds pendulum. Okay. And what's the interesting thing about seconds pendulum? It is a pendulum with a time period of oscillation equal to 2 seconds. So if I have a pendulum and if the time period is 2 seconds, we call such pendulums as seconds pendulum. Why we use the word second? Second means 2, and it is a pendulum with having time period as 2 seconds. That's why we call it as seconds pendulum. And generally we find that the length of the seconds pendulum, where acceleration due to gravity is 9.8 meter per second square, is approximately 1 meter. Yes or no? Just now we have taken the length as 1 meter and we were finding the time period was coming 2. So even this pendulum right now in front of you, whose length is 1 meter, you will find this pendulum can be called as seconds pendulum because its length is 1 meter and where the acceleration due to gravity is 9.8. And the most important thing is this pendulum is the one which has the time period of 2 seconds. Clear class? Okay, so this is called as seconds pendulum. A pendulum with the time period of 2 seconds is called as seconds pendulum. I hope this is very clear to you, all of you. Any doubt, beta? Any doubt, bacha? Okay, chalo. So this is now please make a note. Okay, all of you, please make a note of a homework I am giving you. Okay, chalo, write down the homework. Okay, which you have to do it today itself. Okay, please ensure you solve it. Okay, beta. Page number 24. Numerical I want all of you to write down this, solve these numericals. 6. It's numerical and exercise as well. It's not numerical, it's exercise. Sorry. It's exercise. Exercise 1C. Sixth one. 7. 10. And now write down this 3. After that, write down the numericals. Numericals. 1, 2, 3. 3 is very interesting. Please solve it. 5th. Okay, 5th you will find interesting to solve. And 7. Okay, so please ensure you are solving this 3 plus 5. This 8, it's a small one. It will not take more than 10, 10 to 15 minutes. Okay, so please ensure you are solving this 10 to, you are giving this time. Okay, and another important thing I want to say, so I will stop it now. Now, the another important thing I want to say is that all of you, I'm going to upload this video. Okay, I'm going to upload this video on Google Classroom. After this, I'm going to upload it, and I want all of you to